This video talks about multi-branch statements and nested branching statements. I'm Karen Agar with the University of Georgia, and this video is created as a part of SAIL-CS, the System for Adaptive Interspace Learning for Computer Science. We previously looked at an example that, given a grade, told us if that grade was passing or failing. But what if we wanted to print out letter grades, A, B, C, D, or F, given a grade? How would we do this? Well, we have three different options. The first option is just multiple if statements, the basic branching statements that we learned in the previous video. Here we've got a program where we're going to read in an int grade from the keyboard, and then we're going to determine what this char variable letter is going to be. So I've started writing this using just basic if statements. So if grade is greater than or equal to 90, so a 100, a 105, we're going to assign letter the value of A. So I'm going to do something similar here. If grade is greater than or equal to 80, then let's assign letter equals B. Now this in fact does not work the way that we expect it to, because if I were to run this with the value of 95, then not only would this condition evaluate to be true, but this one would also. So in fact the value of 95 would assign the letter grade of B. The reason that this happens is because when we use these basic if statements, the computer has to check every condition. So even though this one evaluated to true, the computer doesn't stop and skip the others. It continues to evaluate each one. So in order to fix this, we would need to check not only this lower bound of what a B would be, but also the upper bound. So we could say and grade is less than 90. Note that I could have also said less than or equal to 89. Either one works here. But now this condition will only evaluate true if grade is somewhere between 80 and 89. So we can do something similar for C and D. Now what about the F? So part of me wants to say, okay, let's have an else statement because all of these account for A through D. So else letter equals F. So let's stop and think about if this would actually work the way that we anticipate it to. If I were to give this program the value of 95, then this would evaluate to true, so letter would be given the value A. This would fail, so would these two, right? But would we go into this else? Well, the important thing to remember about these basic if-else statements are that this else can only be associated with one if statement, and it's going to choose the one closest to it unless there's curly braces involved telling it otherwise. So what this means for us is that anytime grade is not in this range, so if grade were 55 or if grade were 95, that would make this condition false and we would be assigned the letter grade of F. So we'll run that and see what happens. So I'm going to give it a 99 and it says your letter grade is F. An easy way to fix that would just be to make this another if statement. So if grade is less than 60, we're going to assign it a F. Note that the computer will complain here because letter grade, it thinks, may not have been initialized. Since we're only giving it a value inside these if statements, it never has a default value. So we can easily fix that by assigning it a value up here. Maybe it's an F by default, or we could give it some bogus value just to satisfy the computer here. So now if we run this, this works as expected and correctly assigns letter grades. So we saw using option 1, multiple basic if statements to display letter grades. And this involved having us check both conditions using a Boolean expression, like if the grade was greater than or equal to 80 and the grade was less than 90 to display a B. But this can be tiresome for us to write and is very inefficient for the computer because it has to go through and check the value of each one of those if statements that we provide. So our second option would be nested if statements. This is going to save the compiler time, but sometimes it's not easy to read and can get a little bit confusing. So what we mean by nested if-else statements is we've seen that when we write an if-else statement, we can put other statements inside of the if or the else part. We can also put another if-else statement inside of an if-else statement. This is called nesting. So an if-else can be nested within the if part, the else part, or both parts. So I've started off by saying if grade is greater than or equal to 90, then we're going to assign letter the value of A. So if I were to add an else here, we know this else will pair with this if statement, the closest one. So we're only going to get into this else if grade is less than 90, because that would make this false. So we'll only be in here again if our grade is less than 90. So within this else statement, I'm going to nest another if statement. So I'm going to say if our grade is greater than or equal to 80, then letter equals B. And this would actually work the way that we want it to, because again, if our grade is greater than or equal to 90, we're going to assign the value A and skip over everything else, right? Skip over this else. But if we entered a grade of 85, then this evaluates to false. We're inside this else, and then this could evaluate to true. So we can actually continue in this fashion. So this is an if statement nested inside an else, and if I were to put another else here, then I'm only going to be in this else if I would have had to be in this one, right? So our grade would have to be less than 90. But then in order to get inside this else, remember, it's going to pair with this if statement. So we would only be inside this else if our grade was less than 80. So I can continue in this fashion. If grade is greater than or equal to 70, then letter equals C, and I can continue right here to do the same thing for a D. If grade is greater than or equal to 60, then letter equals D, and else, this final else statement, I'm going to assign letter an F. And so again, remember that I'm only going to be inside this else if I'm less than 90, and then here if I'm less than 80, here less than 70, and then finally if I'm less than 60. So now we've seen option 2 using nested if statements. We saw that this can actually save the compiler time, because if the if statement evaluates true, then the compiler gets to skip over everything inside the else and vice versa. But this can be confusing and not always easy to read. We were very consistent with using indentation and curly braces, but if you're not very careful with these, that it's easy to make a mistake and sometimes can be hard to figure out what's going on. So in this example, I've got the exact same code on both the left and right side of the screen, with the only difference being that I removed these curly braces on the right-hand side. So what I want to know is if these function the exact same way. The answer is no, because we used the curly braces here. It's clear that this else statement is paired with this first if statement. But without the curly braces, we know that our rule is that the else is going to pair to the nearest if statement. This if and this else are both nested within this outer if statement. Again, even though I'm using indentation here to make it look otherwise, indentation does not affect the function of my code. So each else is going to be paired with the nearest unmatched if. You should always use braces, kind of like parentheses, to group statements together. And indentation should be used to indicate which if goes with which else. Remember to be consistent, and that indentation doesn't affect the actual pairings. It's just so we can read it better. So our third option, and perhaps the best option for this displaying letter grades example, is to use multi-branch if-else statements. It's going to save both you and the processor time. Unlike our basic if-else statements that we've learned that only branch the flow of control in two possible directions, multi-branch if-else statements allow you to branch the flow of control in multiple directions. This happens by only checking the next condition if no previous condition has been true. So in normal if-else statements, we have the keywords if and then an else for a default statement. With multi-branch, we add an else if in the middle, and this is the way that it works. So back to our example, I've got if grade is greater than or equal to 90, then we're going to assign letter the value of A. Then I'm going to say else if my grade is greater than or equal to 80, then I'm going to assign letter the value of B. And so this condition, this else if, is only going to be evaluated by the compiler if this condition fails. I can continue with C and D. So else if grade is greater than or equal to 70, C, else if grade is greater than or equal to 60, D. and then add an else, letter equals F. Now again, I want to stress here that only one of these conditions can be executed. So if we entered 95, if grade is greater than or equal to 90, that would be true, letter would be equal to A, it would skip the rest of this, unlike that first example using just if statements that we looked at. So if I run this with 95, then I get my letter is A. If I run it with 75, I get my letter is a C. So this was false, this was false, this was true. It assigned letter the value of C and then skipped the others. And if I run it with an extreme value like 22, I get letter equals F. Now, in all the other examples that we've looked at, we've said that the else statement is associated with the closest if that it could find. It's a little bit different with the multi-branch in that this is one big unit. These are all the different conditions, and if all of these fail, then that's when we go into this else statement. So again, as soon as one of these conditions evaluates true, perhaps if we entered 75, this third condition here would evaluate to true. We skip over the rest of the conditions. So we've seen that with multi-branch if-else statements, we can chain if statements together if there are more than two cases by using the keywords if, else if, and then else. Note that the else where the default statement is executed cannot be omitted and is only executed if none of the prior conditions evaluated to true. So how many statements can execute in a multi-branch if-else statement? Only one. Under no circumstance can more than one of these statements be executed.